Welcome back, everybody, for another deep dive. This time we're taking a look at a fascinating research paper about an AI agent called ROCKET-1. And what's really interesting about this one? It's learned to interact with the world through Minecraft.
Oh, wow, through Minecraft. That's cool.
Yeah, I know, right?
So they're basically trying to push AI beyond just being able to see the virtual world,
Yeah.
and more toward understanding and acting in it. Kind of like how a human player would.
It does sound pretty ambitious. I mean, sure, we all love Minecraft, but what's the bigger picture here? Why is this research so important?
Well, just imagine if we could teach AI to truly understand complex, dynamic environments. I mean, the implications for things like robotics and automation are huge. Think about it. We could have robots that can respond to real-world situations just as well as this Rocket-1 thing navigates Minecraft.
That would be amazing. Okay, so let's break this down a bit. The paper keeps mentioning something called VLM's vision language models. I think I've heard of those, but can you remind us what they are and why they matter so much for this kind of research?
Sure, VLMs are basically the foundation for these intelligent AI agents. They're trained on massive data sets of both images and text, so they can actually understand the connections between what they see and the language we use to describe it. Some of the big names in this field are Gemini GPT-4o and Momo.
Okay, so it's like they're learning by seeing things and hearing people talk about them, kind of how we learn as humans.
Exactly. But even with these super powerful VLMs, there have been some limitations in the past. Like with some models, like RT2, they try to learn everything end to end. And that means they need a ton of data to really function properly.
Ah, I see. So what are some of the other approaches they've tried?
Well, another common one is using what they call hierarchical models. So basically, these have a separate reasoner to plan the actions and then a policy which actually carries them out.
Okay, that makes sense.
The problem is, though, these hierarchical models often struggle to communicate spatial information, effectively.
So, if you told the AI to pick up the blue block, it might get confused if there's a bunch of blue blocks around.
Yeah, exactly. It'd be like trying to give someone directions without using any street names.
Ah, that's a good analogy. So, how does this Rocket-1 thing address these limitations? What makes it different?
So Rocket-1 uses this new communication protocol called Visual-Temporal context prompting. Imagine it like giving the AI a bunch of screenshots from the game, with each one highlighting specific objects. And then with each screenshot, you also give it instructions on how to interact with those objects.
So instead of just seeing a still image or reading a bunch of text, it's getting this much more dynamic view of the world.
Right. And one of the really cool things here is that it uses object segmentation. So instead of just seeing a jumble of pixels, it actually recognizes the individual objects. But then on top of that, it uses this object segmentation from both past and present observations.
So it's actually remembering where things were before? That's pretty wild.
Yeah, it's like it's developing a memory, which is huge when it comes to navigating and making decisions in a world like Minecraft. And to really ramp up that ability, they incorporated SAM2, which is a cutting-edge video segmentation model.
We've talked about SAM2 before. What does it do here?
So SAM2 basically lets Rocket-1 track objects in real time, even if they move around or get hidden for a bit. It gives the AI this constant understanding of what's going on.
That's a huge advantage. Okay, so we've got this AI that understands objects, tracks them, and even remembers where they were. But how did they actually train it to do stuff in the game? Did they just set it loose and hope for the best?
Not quite. They use something called the Minecraft Interaction Benchmark, which is basically a set of tasks designed to really test how well an AI can understand and interact with the Minecraft environment.
Makes sense. So what kind of tasks are we talking about?
Well, one of them is hunt the sheep in the right fence. So it has to really understand location.
Ah, so it can't just know what a sheep is and has to differentiate between them based on their positions.
Exactly. And another one is place the oak door on the diamond block.
Okay.
So now it has to understand the relationships between these objects. These tasks were chosen very specifically to represent skills that would be important for a really intelligent AI.
Yeah, I can see how mastering those skills in Minecraft could translate to some pretty cool real-world applications. So how did Rocket-1 actually perform in these tests?
Okay, so they compared it to some other leading AI agents out there like VBT-Steve-1 and Groot-1. And you know what? Rocket-1 not only outperformed them all, it even completed some tasks that none of the others could even attempt.
Wow, that's impressive. How did they manage to train it so effectively? I mean, we were talking earlier about how some of these models need tons of data.
Yeah, that's where this method called backward trajectory relabeling comes in. It's this really clever way to use SAM2 to automatically label tons of Minecraft gameplay footage. We're just talking about Over 1.6 billion frames.
Whoa, that is a lot. Why is it so important to label all that data in the first place?
Well, think of it like teaching a kid. You have to show them examples and explain what's happening, right? AI is kind of the same. It needs this labeled data to really learn.
Yeah.
The problem is manually labeling that much data would take forever and be super expensive.
So this backward trajectory relabeling thing is like having an AI teacher to train their AI student.
Uh-huh. I guess you could say that. And that's a big part of why ROCKET-1 is so effective.
Okay, so they've got this AI that's trained on a mind-boggling amount of data, and it can handle these shorter tasks. But what about the really complex stuff, like the multi-step challenges that need some serious long-term planning? Can ROCKET-1 do that too?
That's the million-dollar question.
Yeah.
And it leads us to the next part of this research. To tackle those really complicated tasks, they actually combined ROCKET-1 with two other powerful AI models, GPT-4o and Momo.
So they've assembled an AI dream team.
Pretty much. GPT-4o is known for its reasoning abilities. So it acts as the high-level planner. It takes in the whole game situation and breaks down that complex task into smaller, more manageable steps.
So GPT-4o is like the strategist coming up with the plan.
Exactly. And then we have Momo, which specializes in visual understanding. So Momo's job is to actually identify the specific objects that ROCKET-1 needs to interact with.
Yeah.
To carry out each step.
Okay, so Momo's providing the instructions, telling ROCKET-1 exactly what to do.
Yep. And then ROCKET-1, with all its skills with objects, comes in and flawlessly executes the plan.
It's like a perfectly choreographed dance between these different AI models. I love it. So how well does this whole system actually work on those really difficult long horizon tasks?
That's where things get really exciting. They tested it on things like obtaining obsidian, which requires you to find water lava and use tools in a very specific order. And they also tested it on dyeing wool pink, which involves crafting multiple items and understanding a whole process.
Wow, those are definitely not easy tasks, even for experienced players.
Not at all. But get this, ROCKET-1 not only succeeded where other approaches completely failed, it also significantly outperformed them on those tough challenges.
That's seriously impressive. It really shows you what's possible when you combine these different AI strengths.
It does. And it really hints at how this research could go way beyond just gaming.
That's what I'm really curious about. We've talked a lot about the techie stuff and how ROCKET-1 does in Minecraft, but let's bring this back to the real world. Why should the average person care about an AI that can mine diamonds or make pink wool in a video game? What's the so what here?
That's a fantastic question, and it's actually what we'll be diving into in the next part of our deep dive. We'll be looking at how these seemingly simple tasks in Minecraft actually represent some huge breakthroughs in AI research. And we'll be talking about what these breakthroughs could mean for the future of things like robotics, automation, and even just how we interact with technology in our everyday lives.
That sounds fascinating. I can't wait to hear more about it. For now, though, we'll have to leave our listeners on the edge of their seats, eagerly awaiting the next part of this deep dive.
Welcome back, everyone. Ready to dive back in?
Definitely. Let's pick up where we left off. We were talking about ROCKET-1 and all its impressive achievements in the world of Minecraft.
Right. And one of the key things that makes it so successful is this novel approach they call visual-temporal context prompting.
Yeah, I remember you mentioned that earlier. Can you refresh my memory on exactly what that means?
Sure. So it's basically all about giving the AI a richer understanding of the environment instead of just like, throwing a single image or a whole bunch of text at it. The researchers give it a sequence of images, and each one highlights certain objects. It's kind of like, giving someone a tour and pointing out all the important landmarks.
So it's like saying, hey, check out this diamond ore. That's what you need for a diamond pickaxe. Or, see that sheep over there? Yeah, that one's got the pink wool.
Exactly. And it's not even just about being able to identify the objects. ROCKET-1 also uses object segmentation to figure out where those objects are in the scene. And get this, it even uses object segmentation from past observations, too.
So it's not just seeing a random jumble of pixels. It actually understands those individual objects and their positions, like right now, and also where they were before.
That's it. You got it. Most AI agents struggle with this. But ROCKET-1, because of this object segmentation, has a much clearer understanding. It's like the difference between a blurry photo and a super high-definition video.
Makes sense. And you said it uses information from the past. Why is that so important?
Well, think about it. In a dynamic environment like Minecraft, everything is constantly changing.
Right.
Things move, disappear, reappear. By remembering where things were, ROCKET-1 can make much more informed decisions about how to interact with its surroundings.
So it's like remembering that you left your tools in a chest so you know exactly where to go back to when you need them again?
Exactly. And they actually made this memory even more powerful by adding in SAM2, which, if you remember, is a super advanced video segmentation model.
Oh yeah, we talked about that before. What does SAM2 do in this whole setup?
SAM2 acts like this incredibly skilled tracker. Basically, it allows ROCKET-1 to keep an eye on these objects in real time, even if an object moves out of view or is partially hidden. SAM2 can still track it, so ROCKET-1 has this continuous understanding of the whole scene.
Like those nature documentaries where they follow animals through the jungle. You might not always see the whole animal, but you can still track where it's going.
Yeah, that's a great analogy. So now we've got this AI that can do all these amazing things. Recognize objects, understand their positions, remember where they were, and even track their movements. But the question is, how do you actually teach it to use these skills to do useful tasks?
That's a good question. And that brings us back to the backward trajectory relabeling method, right? That sounded super complicated. Can you break it down a bit more for us?
Sure. The whole point of this method is to address one of the biggest challenges in AI research, which is the need for massive amounts of labeled data. You see, AI needs examples to learn from, just like you wouldn't expect a kid to learn how to ride a bike without ever seeing anyone else do it first.
Makes sense. But I can only imagine how time-consuming it would be to manually label every single action in hours and hours of Minecraft gameplay.
Ugh, it would be a nightmare. Seriously, and that's precisely why this backward trajectory relabeling method is so important, because it lets the researchers automate that whole labeling process using SAM2. So here's how it works. They take this huge data set of gameplay footage, and they identify the frames where an interaction happens, like mining a block or crafting an item.
Got it.
Then they use SAM2 to work backward, labeling the relevant object in each of the previous frames.
So if the AI mines a diamond block in frame 100, SAM2 goes back and helps identify that exact same block in frame 99, 98, 97, and so on. It's automatically labeling it in each frame.
Exactly. It's like they rewound the game and said, okay, we know the player interacted with this object right here, so it must have been present in these other frames too. That way they create this super detailed map of the object's location and movements throughout the whole game.
Yeah.
And they don't have to label anything by hand.
It's like an AI time machine, going back through the footage and pinpointing those exact moments when an object was interacted with.
Uh-huh. I like that. So they've got this massive data set of labeled footage now. What do they do with it?
Yeah, good question.
Well, this labeled data becomes the training ground for ROCKET-1. The AI agent analyzes this giant library of interactions, and that's how it learns to identify different objects, understand their properties, and predict how to interact with them to reach specific goals. It's like studying the ultimate Minecraft encyclopedia.
So it's not just learning specific actions, it's learning the overall strategies and principles of the game.
You got it.
Yeah.
And the coolest part is it's not just limited to the specific tasks it's trained on. Because ROCKET-1 learns from such a diverse data set, it can actually generalize its knowledge and adapt to brand new challenges it's never even seen before.
That's what separates the truly intelligent AI from the rest, right? That ability to adapt.
Absolutely. And that's why this research is so exciting. It's not just about making an AI that's really good at Minecraft. This is about understanding the fundamental principles of learning and intelligence, and then applying those principles to real-world problems.
Which brings us back to that so what question. How do we translate these advancements from a video game into real-world applications?
Imagine robots that can navigate through complex environments, like construction sites or disaster zones. But they do it with the same level of understanding and adaptability as ROCKET-1 shows in Minecraft.
So instead of programming robots for every single specific task, we could have robots that can actually learn on the fly, adapt to new situations, and understand really complicated instructions. That would be a game changer.
Absolutely. And it goes beyond just robots, too. Think about AI assistants that could understand your visual environment and offer you personalized help. Imagine an AI that can help you cook by recognizing the ingredients in your fridge or guide you through fixing something by understanding the tools in your workshop.
That would be amazing. It'd be like having a partner who can see what you see and knows exactly what you need. But as impressive as all this is, there have to be some limitations to this approach, right? What are some of the challenges the researchers are facing and what's next for them?
Those are great questions. And actually, they're the perfect segue into the final part of our deep dive. We'll be talking about the challenges of creating truly intelligent AI, the limitations of what we have now, and all the amazing possibilities for the future as this research keeps advancing.
I'm looking forward to it. Our listeners have a lot to think about as we head into the last part of this episode. All right, welcome back to the final part of our deep dive into the world of ROCKET-1. We've covered a lot of ground, from how it works to what it can do in Minecraft.
And we've even touched on how this research could impact things like robotics and AI assistants.
It's been fascinating. But like any research, especially at this cutting edge, I'm sure there are challenges and limitations. What are some of the hurdles they're facing trying to take this AI even further?
Well, one of the biggest challenges is, creating AI that can really generalize its knowledge and adapt to completely new situations.
Hmm.
Rocket One's been amazing at transferring its learning to new tasks within Minecraft. But Minecraft's still a very controlled environment, right? The real world is way more complex and unpredictable.
True. Even with all its advancements, Rocket One is still living in a video game. So how do we bridge that gap between virtual and real?
That's the big question. And it's a key focus for a lot of researchers. One thing they're trying is to build more realistic and complex virtual environments that are closer to the real world.
Makes sense.
And they're also trying to develop ways for AI to learn from data that hasn't been labeled, which would give it so much more information to work with.
So it's like teaching AI to learn not just from structured lessons, but from just observing the world around it, like how we do.
Exactly. Now, another thing to think about is the hardware side of things. Can our current robots even handle all these advancements in AI software?
Yeah, it's like having a brilliant mind stuck in a clunky body.
Uh-huh. That's one way to put it. We've made incredible strides in AI, but robotics hardware is still playing catch-up.
Seems like these two fields need to work together.
Right.
Advancements in one push the other forward.
Exactly. And that's what makes all of this so exciting. It's not just about AI in isolation, just about all these different disciplines working together to figure out how AI can benefit humanity.
So we've got these amazing advances in AI, but also some big challenges to tackle. What's next for Rocket One and the team behind it? What are their goals for the future?
Their ultimate goal is to build an AI that can understand and interact with the world just as effectively as humans do.
Huh?
But of course in a way that's safe, ethical, and, actually good for society.
That's a pretty tall order.
Yeah.
What are some of the things they're working on right now?
Well, they're still refining Rocket One's abilities, looking for new ways to train it and collect data, and developing new tests to see how it performs in more complex situations.
So pushing it further and further.
Yeah. And they're also looking at how to make the AI more transparent so we can understand how it makes decisions and make sure it aligns with our values.
Like teaching it to show its work so we can understand its reasoning?
Exactly. And all of this has the potential to completely change how we live and work, from how we interact with technology to how we solve global problems.
Wow. It's been an incredible journey exploring the world of Rocket One and the future of AI. As we wrap up this deep dive, what are some of the key takeaways you hope our listeners will ponder?
I think the biggest one is that AI is not some distant sci-fi concept anymore. It's happening now. And it's already having a huge impact on our world. Rocket One is just one example of all the amazing progress being made, and it gives us a glimpse into what the future could hold.
And it reminds us that AI isn't just about algorithms and code. It's about understanding what intelligence really is and how we can use that understanding to build a better future.
Absolutely. And as we explore these new frontiers of AI, we have to do it thoughtfully and responsibly to make sure this technology is used for good.
It's been an incredibly provoking conversation. Thank you for sharing your expertise with us.
It was my pleasure.
And to our listeners, thanks for joining us on this fascinating journey. We hope you'll keep exploring the world of AI and all its possibilities. Until next time, keep diving deep.